modes are simply the different ways a microprocessor can access data, either from registers, memory, or directly from the instruction itself. I will also discuss the answers in the 5 exercises given. This includes identification of addressing modes, write code for specific addressing modes, address calculation, for the debug and analysis, and for the practical problem. So, let's begin. In the first exercise, we were asked to identify the addressing modes used in the several numbers. For examples, move AX BX uses a register addressing because both operands are registers. Move AX 1, 2, 3, 4H uses direct addressing because the instruction points to a specific memory address. Instructions like move AL SI and move DIAX uses register indirect addressing since the registers SI and DI act as pointers to memory. For base index addressing and base index with displacement, we have instructions move BP plus DIAX and move CX BX plus SI plus 08H. The CPU calculates the effective address using multiple registers plus an added displacement value. Immediate addressing move AX B678H uses immediate addressing where the data itself is provided directly in the instruction. Move AX BP minus 10H is also the same as number 4 as the base index addressing. And let's proceed to the second exercise, which is the write code for specific addressing modes. We demonstrated different addressing modes using short 8086 assembly code snippets. For immediate addressing, we use move AX55AAH to load the value directly into AX. For register addressing, we move AXBX simply copies data between registers. Direct addressing is shown by move AX 1234H, which retrieves data from a specific memory location. Register indirect addressing is seen with move AX SI, where SI acts as a pointer. Index addressing is demonstrated with move AL DI plus 10H, and base index addressing is seen with move AX BX plus SI. This instruction shows how each addressing mode controls where values are taken from during program execution. For the third exercise, we have address calculation. It involves computing physical addresses. For the direct addressing example with move AX 1000H, we use the segment address 2000H using the formula physical address. Using the formula, physical address is equals to segment times 16 plus offset. We compute 2000H times 10H is equals to 20,000H, and then add the offset, which is the 1000H, to get the final physical address of 21,000H. For the base index with displacement example, the values BX and SI are added together with a displacement to get an offset of 5565H. Adding this to the segment base address of 20,000H results in the physical address 25,565H, which is this one. And for the fourth exercise, the debug and analyze, we analyze a short code snippet. Move AXSI uses register indirect. We have to analyze the following code snippet and then answer the following identify the addressing modes used in each instruction. For move AX SI, it uses register indirect addressing, while move SI 2000H uses immediate addressing. Sorry for this. While move Then the instruction add AX SI plus 10H uses index with displacement addressing, with displacement. Then finally, for the move DI-AX, it uses register indirect addressing. Given the data in memory, 1234H at 2000H and 5678H at 2000H plus 10H, the resulting value of AX becomes 1234H after the first instruction and then becomes 68ACH after adding 5678H. And that is the answer for the question number 2. If the value at the memory location 2000H is 1234H and at 2000H plus 10H is 5678H, what will be the final value of AX? The final value of AX will be 68ACH. For exercise 5 practical problem, write a small assembly program that loads the value 0xabcd into the memory location 300H, retrieves this value using direct addressing mode and stores it in AX, copies the value from AX to BX using register addressing mode, stores the value in BX at the memory location pointed to by DI using register indirect addressing mode, assume DI is 4000H, and we wrote a small assembly program. First, we store ABCD into memory location 3000H using move 3000H ABCDH. Then, we retrieve this value into move AX 3000H and copied it into BX using move BX EX. Finally, assuming DI is 4000H, we stored BX into memory using move DI BX, which uses register indirect addressing. This short program combines multiple addressing modes in practical tasks. So, that concludes my explanation for this activity on microprocessor addressing modes, and I discussed how to identify different addressing modes, how to apply them in assembly code, how to compute physical addresses, and how to analyze short program segments.